Hello students, so now let us do question 5th of the exercise 1.1 for the chapter real numbers. So the question 5th is use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. In order to solve this question, let us take two unique numbers say a and b such that a is greater than b. Then on dividing the number a by b, two unique numbers will be obtained where q is called the quotient and r is called the remainder. The relation between a, b, q and r can be represented as a is equals to bq plus r, provided with the conditions on the values of r is that r value can be greater than or equal to 0 but less than b, where b is the divisor. Now suppose in this very case b is equals to 3, which means that divisor is equals to 3. Then a will be equal to 3q plus r, where in this particular case r value can be greater than or equal to 0 but less than 3, which means that the set of value which r can take is 0, 1 or 2. Using these three values, the form which the number a will take can be 3q plus 1 or 3q plus 2, which means that three forms are possible for the number a if the values of r will be 0, 1 or 2. So now let us take the first form, that is a is equals to 3q. Now taking the cube on both the sides, that is a cube will be equal to 3q cube, which will be equal to 27q cube, which can also be written as 9 into 3q cube or equal to 9m. Because as we know q is some integer, so the cube of any integer is also an integer multiplied by 3 will result into integer be it m. So here a cube will be equal to 9m. Now let us come to the second form, that is a is equals to 3q plus 1. Now taking the cube on both the sides, that is a cube will be equal to 3q plus 1 whole cube, and using the identity of the a plus b whole cube will be equal to 27q cube plus 1 plus 27q square plus 9q. Now taking the 9 common from the first, third and the fourth term, in the bracket we will be left with 3q cube plus 3q square plus q and the second term, that is plus 1. And as we know the terms involved in the bracket are integers, so the arithmetic addition or multiplication applied on some integer will form another integer, let it be an integer m. So here in this case a cube will be equal to 9m plus 1. Now let us take the third form, that is a is equals to 3q plus 2. And now taking the cube on both the sides, that is a cube will be equal to 3q plus 2 whole cube. And using the identity over this, here a cube will be equal to 27q cube plus 8 plus 54q square plus 36q. And now taking the 9 common from first, third and last term, here in the bracket we will be left with 3q cube plus 6q square plus 4q and the second term, that is plus 8. And here also we can see that the terms involved in the brackets are some integers, so let this be integer be m, and then in this case a cube will be equal to 9m plus 8. So all the three forms which are possible for a cube are 9m, 9m plus 1 or 9m plus 8. Now let us verify the result which has been obtained, that whether or no the value of a on cubing will result into these three forms or some other forms also. So for the verification, let us first take the value of a is equals to 3. Then a cube will be equal to 3 cubed, which is equal to 27, or which can be written as 9 into 3 or equal to 9m, where here m is equals to 3. Now let us take another example where a is equals to 4 on q being the a, that is 4 cube will result into the number 64, which can be written as 9 into 7 plus 1 or 9m plus 1, where m is equals to 7 in this case. Now let us take an example where a is equals to 5, then on cubing the a, that is 5 cube will result into 125, which can be written as 9 into 13 plus 8 or 9m plus 8, where m is equals to 13 in this case. That is, if we take the value of a is equals to 3, then 9m will be obtained for a cube. If a is equals to 4, then 9m plus 1 will be of the form of a cube. If a is equals to 5, then 9m plus 8 will be form of a cube. So, like this, we can take any number. So, the form obtained on cubing that number will be either 9m or 9m plus 1 or 9m plus 8. So, this was all about for the question 5th of the exercise 1.1. I hope this question is clear to all of you.